Hello, everyone. This is Amit. First of all, thank you for taking out time to attend this webinar. The topic of the webinar is value-laden and ambitious. I'll try my best to do justice in my best capacity. Over the next 30 or 40 minutes, we'll be talking very briefly about what is autoML, a very short demo of our autoML tool called Clonizo. And most of the time, we'll be spending time talking about how to think of various use cases, collecting data, and other considerations if you are thinking of choosing an autoML product. So that's me. So let's get started. Quickly, just so that all of us are on the same page, what is machine learning itself? At least conceptually, all of us understand that, at least in what is known as supervised machine learning, you train a model based on historical data and expect the model to capture various patterns in your data, right? And later this learning is used to make real decisions on the new data. So this is in a nutshell what machine learning is, right? But the implementation of machine learning is complex. It requires brilliant programming skills, statistics, and problem solving. That is why raising a data science team is a challenge and it is of course a costly exercise. Now, AutoML is nothing but the automation of most complex pieces of machine learning experiment. We in the Clonizo team believe that machine learning is going to be a commodity in the so-called fourth industrial revolution, much like how electricity and internet have become commodities from the previous industrial revolutions. And it appears that the current COVID-19 crisis is just expediting this commodification. So as a consequence, AutoML will no longer remain a coding nightmare as machine learning used to be, but the focus really will come on how to identify the right problems, right use cases, and how to choose the corresponding data to solve the most teething problem of your business. Data is definitely mandatory. If you are in the control of data, that's where lie various patterns, and you should be trying to figure out various answers for your business problems. But wait, this is a quote from Picasso, and this is alluding to something else. What it means is that more than getting a handle on your answers, it is more difficult to ask the right questions. And if you ask vague questions to your data, you are going to get back only vague answers. And you don't want to do that, of course. So even before we get down to the details of the data, let's focus on how to frame questions or use cases for your AutoML experiment. So let's look at examples of some use cases. For example, somebody asking which customer segment can contribute to increasing the revenue by 5%, or how can I improve my customer conversions by 2%, or even how can I make my website more engaging. Now contrast these examples with these, which is which customers are good prospects to cross-sell a new product X, or which customers are going to become 90 DPD defaulters in the next 6 months. Or similarly, a requirement of forecasting of some SKUs at a store level in the next month, right? So what you see in the orange, right? These cases, these examples are much more specific, less subjective. They definitely have greater ROI attribution, right? So this is really the difference between a good use case and a bad use case. But reality of life is not gray and orange as it appears on this slide, right? Reality is complex, and it would be a really good idea if we had a heuristic device with which you could think of listing and spelling out various use cases about your business. That's what we are going to talk about next, which is our so-called the sacred framework. Now, sacred framework is consisting of 6 dimensions, and any use case that comes to your mind, you should be judging that use case based on these 6 dimensions. So let's look at them one by one. First, you should make sure that the use case that you have in mind is statistical. What that simply means is that if you asked answers to a question 10 different people in your organization, all of them should not be varying too much. If they are varying too much, that means it's a very subjective question to be asked, and this is a very poor candidate for making a machine learning use case. Next, the use case must be assigned to an owner, or maybe more than one, but someone must be accountable for the entire exercise. This is an ML exercise, and once the model is ready, it is going to influence real business decisions. So for something as impactful as this, somebody must own the process so that we can reach out to him in case of any issues in the future. With that taken care of, you should have a high-level idea about the cause and effect relationship between what the so-called target variable and the number of variables, number of factors that are influencing it, right? And we are going to dig deeper in this dimension in the next slides. But yeah, causality is an essential component of a use case. Next, the data that is involved in the use case should be available repeatedly. The business segment should be able to generate fresh data. And that essentially is the utility of having a machine learning model on which you should be testing the new data on, right? Now, next, 5th dimension is very important, which is about exposure of the use case that you are building. Now, you could be thinking of building a, say, automatic employee firing system for your organization, right? But that may not go well with other internal stakeholders, or maybe with the regulators. So keep in mind, try implementing use cases which have less exposure as opposed to the ones which have more exposure, and you need a broader consensus to go ahead with them. Last thing is about money, in the sense the use case should be very specific so that when things change, when you have your machine learning model in practice, and if things are changing, you should be able to attribute some return on investment on it. Now, any of these 6 dimensions seemingly does not give you a clear yes or no answer, right? This is going to be a graded answer based on the specific use case. So it would be a good idea if you could score a use case on each of these 6 dimensions. And all the use cases that you have thought of, you could score each of them and plot on something like a radar plot, right? And quantify each of them, visualize them, and then rank them, which one you want to proceed with first. Now, with that said, we have listed the use cases, prioritized them. Now it's the time to think about data. So again, we are back to causality. We are taking use cases one by one. And now it is the time to sit with your team, brainstorm, and think of as many factors as you can think that influence your target variable. Use your favorite analytical framework, of fishbone diagram, of 5 whys framework, anything. Just stretch that cause and effect chain as much as deep as and as broad as possible, right? So the details of such an exercise will definitely vary depending on the business that you are in and the use case that you are considering. But from the first slide that we looked at an example, let's take an example of credit card delinquency. So somebody going 90 DPD delinquent, and in case you don't understand what DPD is, delinquency is simply defaulting on your credit card bill. So that being your target variable, let's start thinking about grouping the factors into, say, external factors and internal factors, and consider internal factors first. Let's further break it down into more components. Here I'm displaying just three, which is product, customer, and pricing, right? So think of how credit card as a product, what kind of characteristics must be influencing delinquency, right? So could be your product type, whether it's a platinum card, gold card, what is and what is the overall rank of this product in your own portfolio. And then third could be the rank of this product in the segment that you work in. So that would be a comparison vis-a-vis the other peers, right? Similarly, about the customers, you could be thinking of demographics, you could be thinking of how the customer was acquired, what has the relationship with that customer been like. Similarly, under pricing, you could be thinking of discounts, the discounts you have offered, the number of discounts that he has availed, rewards, and different offers, right? So you could be further breaking this level down even at a next level of granularity, right? And preparing a list of everything possible under the head of internal variables. Now, you do the same exercise with the external variables. So again, taking just three examples here of regulatory variables, competition variables, and variables related to public policy. Public policy under which is like public health becomes very pertinent here because of the current crisis. But there could be demographics that you think impact your product, that particular product. There could be various tax incentives either induced by current crisis or otherwise. Similarly, what the competition is doing, how are they acquiring customers, what are the kind of discounts they are offering. And then regulatory factors such as if there are raw material restrictions or some priority lending restrictions, for example, the way RBI does in our case. So you do the same exercise to prepare the list of external variables. Finally, your schematic picture of your variables list would look like this, having a mixture of internal and external variables. And once you are done with your variables, you do a final sanity check on them. You can build a simple matrix like this. You want to make sure that the attributes that you have listed, they are available, they are accessible to you, you have the control over that data. The data is authentic, it's not corrupt, it is repeatedly being generated, and a couple of data types just to get a comprehensive detail on the data set. So this is the sanity matrix you could pass your variables through. And finally, this exercise results into something like this. So this becomes your curated data for training, which has a group of internal variables, external variables, and the target. And target is the historical labels, the way in this particular example, the way previously your credit card holders have behaved. Now, once you are ready with this training data, let's see how it works in action. So I'm going to take you to the Clonizo interface. I'll exit this presentation. And yeah, we are in Clonizo interface. So this is my browser, and I can access this tool from the browser. First thing I do, if I have training data ready, is I create a project. Give it a name, say project 6. Now, this is the binary classification. This is the task type I'm choosing. And I chose this task because essentially we are working on the problem of delinquency. So from a group of my my credit card holders, I'm trying to identify which of them are going to become delinquent, basically bad customers, and which of them are going to remain good customers. So it's a basically segregation of good and bad customers. That means it's a binary classification problem. With that, I say create, and what you see at the top is what we call autoML pipeline. And we are at the second step. Depending on which stage you are at in the pipeline, that step will be highlighted. Currently, this is asking us to upload the training data. That's what we do. I go to training data, choose it from a local file, and ask it to upload. On the right hand side, by the way, you see a project postcard which has key details about every project on the right hand side. And as you progress in the machine learning pipeline, this this card accumulates more and more details. So as of now, it just has two variables. When we move forward, we make few more choices. It'll have all those details here listed. So few more seconds for it to complete the upload. It's a big file, so it's taking a bit long, and we are done. Yeah, so it takes me to the next screen, which is nothing but the data preview of what we just uploaded. We have two columns. One is column type and data type. So in column type, I first go and choose the target variable, and my target variable is named as target only in my training data. And then if there are some ID variables, if there are there, I'll mark them as ID variables and say upload. All right, so now we are at the next screen, and so-called the feature engineering screen. Does not matter. It is just one of the steps involved. What we see on this screen is basic statistics of the data, training data that we just uploaded. The rightmost column is about missing values. If your data has some blanks, it will highlight them here. Optionally, you could tweak them. Otherwise, it is going to do its default thing. Literally, even if you don't do anything, it will take care of everything. And on the right hand side, you could just go and click on train model, which is what I do. And the training starts, of course. Now, given that this is a big data set, it's going to take some time. So I'll quickly abort this one and show you a prepared model on the same data. So in this screen, we are at the performance screen. And what we see is the model performance. So these are various parameters. I'm sure if you have some understanding of how a classification model works, this would make instant sense to you. But otherwise, you could take help of some experts and make sense of what these metrics mean. What we can do from here is that the model is ready. I can go to the predict screen, and predict screen looks much like the training data upload screen. And here, what I'm doing is, give me a second. Oh, let me refresh this. Sorry for that. Now, with that understanding, let's come back to the main presentation. So we have understood how to build a model. The model is ready, hosted on Clonizo or any other platform for that matter. Now, you of course want to utilize that model. That's the essential purpose of having it in the first place. So based on our understanding, there are mainly three categories, three ways in which you could use your models that are hosted on an AutoML platform. First is the set of existing enterprise apps that you have in your organization. And depending on how open those applications are, and of course, the AutoML product's capability to provide them a few click easy integration with those tools, that should be one criterion. So if the AutoML product provides easy integration with your existing suite of enterprise apps, that should be given some weight. On the left-hand side, left and top side is anything that is being developed, any coding software development that is happening in-house in the organization, they should be able to use access models hosted on the product through an API and really an on-demand based kind of machine learning usage. And on the left-hand side at the bottom is really the table, the kind of prediction that we just saw, which is you upload the test data and get a column added to your Excel sheet about the predictions, and then use that table in any manner that is most feasible for you. So these are basically three criterion on which you could be assessing your AutoML product. Now, quickly, before we reach to the last segment, taking care of few more things. So we talked about how to establish the use case, collect the data, sorting it, sanitizing it. We also saw how to build a model, how to use it. Now coming back, before you even start a use case, you should be able to, as objectively and as accurately as possible, establish the baseline, because that's where you will start counting and sort of benchmarking what is the value add that AutoML is creating for you under that particular use case. Second, you have to guard really the perceptions of both internal stakeholders as well as the external ones. People don't really trust in general the machine learning systems, machine learning decision making systems. So if people might be wary of the accuracy of the decisions, they might ask for more explanations that might add to more complexity in terms of explainability of your models, etc. And then keep comparing your models outcomes with the real life values of your data, and keep guarding it closely so that if the deviation between what the model is predicting and what the real outcome is, if the variation between the two is more, this is the time to retrain the data, provide it fresh training data, and if possible, if you think, include or delete more number of variables. So it's really your baby, it's not a one-time thing, and it keeps on evolving as you evolve in your business. Now, before we conclude, let's quickly talk about if and are you AutoML ready. So should you be AutoMLing your organization or your team, right? So this is very critical. There are many things that one could consider here in this segment. But first is the speed at which you want to build and ship your machine learning models. Especially in a COVID-like crisis where customer behavior is changing so rapidly and there's an influx of external variables almost every week, you might want to build and ship models on a weekly basis, and that might become a very difficult project for an in-house ML team. So if you are about to do that, if you're thinking of doing it, AutoML should be your choice. Second, given the new work from home arrangement and other changes that have been created by the current crisis, a genuine reason could also be to enable the non-experts to get a handle on the ML experiments of your organization. So now an AutoML product like the one we saw just now is a simple browser-based UI-based tool, and within a few clicks, even a non-expert can tinker with creating and designing ML experiments. If that's your priority, sort of extending the ML capabilities beyond your core ML team, then AutoML becomes your default choice. Third, the costs. Raising and maintaining an ML team incurs high OPEX, definitely. So even if you have plans to raise an in-house ML team for some reason in the future, AutoML could act as a precursor for you to see the tangible value that certain use cases might bring to you from an ML perspective. Yeah. And of course, the last is and again a very pertinent thing is to take into account the licensing costs, the technical and data science support that a tool offers, and of course the business bandwidth that will be going into either listing out the use cases or figuring out which data sources are relevant for that. So these are a few considerations if you are thinking of onboarding an AutoML product. And yeah, with that, we conclude this presentation. I hope this was helpful, and thank you so much. You've been a wonderful audience. For questions, comments, and suggestions, please feel free to reach out to me on my email that's being displayed, and you could also connect with me on LinkedIn. Thank you once again.